Hello everyone, this will be your pre-lab lecture for the dehydration of an alcohol lab, right? So this is a reaction that we went through ad nauseum during lecture, and you're actually going to be able to see it virtually happen here. So I wish you could do it actually in lab itself. Lab is always more fun when you can do it yourself and do the action yourself. But simply what's happening here is you're going to take a molecule known as hexanol, right? You're going to do a dehydration reaction with that thing using phosphoric acid, right, and some heat, right? H3PO4 and some heat. Some people write out the word heat, some people put a triangle there, whatever it could be, whatever it is, right? And what you're going to get from that is you're going to get a cyclohexene, right? So literally this is a dehydration reaction. And this is again, we talked about this ad nauseum in the alkene section of our lecture, okay? And quite simply, the reaction works just like this, right? We can start out with the acid here, which is H3PO4, but I don't have to write that out every time. So I'm just going to put AH, no, maybe not AH. Maybe I'll put HA. There we go. Okay, we'll do HA. And so the lone pair of the alcohol will come over and pull off that proton, leaving those pair of electrons with the conjugate base. Okay, so then you have a water up there, right? A water up there, along with a minus, which is the phosphate ion. I just don't want to write it over and over and over again. Okay. So after that happens, we know that water is a good leaving group, right? So water will just leave, okay, leaving you behind with a carbocation, like so, right? And then a proton over here can get deprotonated by the conjugate base, and then this goes down like this, right, towards the carbocation, and we end up with the cyclohexene, right? Good stuff. So the dehydration reaction is quite simple, and that's what you'll be doing today in lab. And the way you'll be doing it virtually, right, is you'll have a flask, right, round bottom flask. Again, I never am good at drawing round bottom flasks, but it's going to be, you're not, instead of doing a fractional distillation like you did in the previous lab, you're just going to be doing a small microscale distillation. And the difference is that there won't be that much of space for the gases to travel, right? And then you'll collect stuff over here, okay, and a little beaker over there, and in the pot here, while it's heating inside of a heating mantle, right, you'll have a mixture of cyclohexanol, which is this, and phosphoric acid. Okay, does that make sense? Good stuff, right? And then you'll do it's almost like a small reflux and distillation, and you'll collect the stuff over here. And then once it gets over here, you'll transfer everything in here into, you could use a separatory funnel, but there's not that much of it, so you'll put it into a test tube, right? And you'll get a layer, 2 layers, right? And what you want to do is figure out which is the aqueous layer and which is the organic layer. And you're going to keep the organic layer. Okay, I won't tell you what that is because you'll find out during lab. And once you get the organic layer, you'll have it in that flask, not the flask, the beaker, and you'll add a drying agent to it, right? So you can get all the water out of it. And then after you get all the water out of it, you'll filter it all out, right? And then you'll have your sample in possibly another test tube after having it all dried out. And then what you do is you'll take an IR of that. And so since you're doing this online, the IRs will already be given to you. So you'll have an IR of the cyclohexanol, right? You have an IR of that, which is the starting material. And then you'll have an IR of this one, which should be hexene, cyclohexene, right? It should be cyclohexene in your IR, right? And you can note the differences between those two IR spectra, right? Remember that when you have an alcohol, right, you'll have a big, happy face looking thing coming down like this at around 3,400 wave numbers, right? 3,400 wave numbers. But then when that alcohol gets turned into an alkene, the cyclohexene here, right, then you'll get a bunch of peaks near the double bond region, right? So that's basically the lab that you're doing today. It's pretty simple. Of course, request the data from the report submissions tile, and then also look at the PDFs that are provided, because one of the PDFs is the instructions for the lab, and then the other PDF is actually the spectra of both your starting material, which is the cyclohexanol, and then the IR spectra for the products, which is the cyclohexene, right? Makes sense? Good stuff. All right, good luck on lab today, and also good luck on your exam tomorrow.